Okay, start with your name and date. The lesson today is 5.3, Linear Relationships and Bivariate Data. This would be pages 141 through 148 in your book. Question: how can you contrast linear and nonlinear sets of bivariate data? We have vocabulary. I've already written it down. If you need to pause the video in order to get all of it copied, do so. Linear, data that forms a line when graphed. Nonlinear, data that does not form a line when graphed. Bivariate data. This is the one that we are really paying attention to today. It's not new. We're talking about data that is made up of two paired variables that change in some way. And we come up with that. Bi is the prefix that means two. Vary, it refers to the variable or to the fact that it varies or changes. Now we also need to get in here a slope formula. And we've already talked about this one. Okay. Our slope formula, M of course meaning slope. When you have 2 points, you name one of them your first point, one of them your second point. That's what the subscripts refer to. Okay? Y sub 2 minus y sub 1 over x sub 2 minus. Please be aware, this comes from 1 point. This one is the other point. And it's always y over x. And then we've also talked about the y-intercept. And in our equation that we've used, b is the y-intercept value. It's where the line crosses the y-axis. And our equation that we are using is the slope-intercept form of y equals mx plus b. Notice we are using the same variables that mean the same thing. M is our slope, that is your coefficient of x. B is your y-intercept value. Now we're going to be looking at some examples. Our first example comes from page 141 in your book. And I have a copy of that page, and that's what I'm going to use. A handrail runs alongside a stairway. As the horizontal distance from the bottom of the stairway changes, the height of the handrail changes. Show that the relationship is linear, then find the equation for the relationship. And they have plotted some points here. Notice the horizontal distance, and that's going to be from the bottom of the stairway. So you're counting from the bottom of the stairway. This is the height of the handrail. So when you are 5 feet from the bottom of the stairwell, then you're at 7 feet for the height of the handrail. And that continues 10 to 11. 15 to 15, 20 to 19, 25 to 23. Show that the relationship is linear. Well, if you can take and draw a line, line up those points, and draw a line through those points, then it's linear. Write the equation of the linear relationship. You have several points. You can choose 2 points to find the slope. They're going to use this point here and this point up here. So 23 minus 7, what they did is they said this was our second point, this is our first point. They used that slope formula. Okay, so 23 minus 7, 25 minus 5, that works out to be 16, that works out to be 20. I prefer fractions, so that would be 4 over 5, which is the same as 0.8. Choose a point of the slope to substitute values for x, y, and m. You use your slope-intercept form of the equation. You just found your slope to be 0.8. They're going to use that first point, so they're going to put 7 in for y, 5 in for x. 4/5 times 5 is 4. So now we have to figure out, how can I figure this out? Well, I can subtract 4 from both sides, and 4 minus 4 goes to 0, leaves me just the b. 7 minus 4 is 3. So we have a b value of 3, a slope formula, or a slope value of 0.8, and we just fill it back into that equation. Y equals 0.8 x plus 3. And there's your equation. Then we're going to do example 2. Again, it's in your book. This one is on page 142, and it goes to page 143. We're going to make some predictions here. Graph shows the cost for a taxi ride of different distances. Predict the cost of a taxi ride that covers a distance of 6.5 miles. So this is some information that we know, and we're going to have to predict if we need to go 6.5 miles, what's it going to cost us? So you find your points. That's 2, 7. That looks like that's 4, 11. That would be 6, 15, which is the other point that the book is going to use. Find the slope. And they did. 15 minus 7, 6 minus 2. That's 8. That's 4. 8 divided by 4 is 2. So my slope is 2. Okay, and I can find the b by doing what we just did again. I'm going to use 615 this time, it looks like. So my slope is 2. My x is 6. My y is 15. That's 12. I would subtract 12 from both sides so that b is 3. So my equation then would be y equals 2x plus 3. And that gives me my equation. If you turn that page and go to page 143 at the very top, then it takes that equation we just found, substitute 6.5 in. 2 times 6.5 is going to be 13. 13 plus 3 is 16. So a 6.5 mile taxi ride for this company is going to cost you $16. Now we need to really look at bivariate data, and we're going to do that by doing the Explore activity on pages 144 and 145. So let me write that one down. Now, understand you can add notes in here if you need to, if you want to book pages, and that should be helping you. Bivariate data is a set of data that is made up of 2 paired variables. If the relationship between the variables is linear, then the rate of change, or the slope, is constant. If it shows a nonlinear relationship, then that rate of change changes. It's not constant between pairs of points. And they give us a problem to look at. Andrew has two options in which to invest $200. Option A earns simple interest of 5%, while option B earns interest of 5% compounded annually. The table shows the amount of the investment for both options over 20 years. Graph the data, describe the differences between the two graphs. So I'm going to use my blue pen for option A. Okay, so 0, $200. 5 is 250. 10 is 300. 15 is 350. And 20 is 400. Okay, now that's graphing, and I'm going to work with just option A right now. We have some questions down here at the bottom. It says find the rate of change between pairs of points for option A and classify the relationship. Okay, so if I do first and second point, then 250 minus 200 is 50. And 5 minus 0 is 5, which that equals 50 divided by 5 is 10. So if I do the same thing for the next 2 points, I get 300 minus 250 over 10 minus 5. Well, again, that's 50 over 5, which is 10. This one is 350 minus 300, 15 minus, again, 50 over 5, or 10. These are the same. These are constant. So what I'm going to fill in here is that the rate of change between the data values is constant, so the graph of option A shows a linear relationship. The other way that you could figure that out is to take your ruler, your straight edge, and if I were to draw a line, those points would form a straight line. Okay, I'm going to use green for option B. So let's go back and graph this. 0, 200. Then it's 5 to 55.26, which is a little above that. 10 is 325.78. 15 is 415.79. And 20 is 530.66. Now, if I were to take my ruler, I can't line those up and form a line. So I'm already suspecting this is not going to be linear. If you go to the top of page 145, they have, again, find the rate of change between pairs of points for option B and classify. Well, they use those 2 points. 255.26 minus 200 is 55.26 divided by 5, which is approximately 11. Then we're going to do 325.78 minus 255.26 over 10 minus 5. Well, the bottom's easy, that's 5. And I'm going to 25 and 255. That's 70 divided by 5, which is approximately 14. Then I have 415.79 minus 325.78. Again, I will guesstimate that in just a moment. Oops, that's minus 10. That one's easy, that's 5. That looks like that's 90, or 90. And so that's going to be approximately 18. these are not the same. These are not constant. And so this is a non-linear relationship. Okay, so let's add some notes to our spiral after doing these problems. Okay, here we're contrasting with bivariate data. In A, we found if the rate of change is constant, the relation is linear. So if it's constant, it's linear. In B, if the rate of change is not constant, the relationship is nonlinear. Not constant, nonlinear. Okay. And your quick check. You're going to look at pages 142 through 145. And you're going to do all your turn and reflect questions. That would be numbers 1 through 11. Do all 11 questions.